All right. Hello, everyone. How's everyone doing today? Today, Sunday, the 13th of September, 2020, we have a very, very special guest for you on Coby's Brain, Joey Murphy. We got Joey Murphy in the house. Sorry, what was that, Joey?
Just saying, happy to be here.
We are very honored to have you. So, as some background, Joey studied physics at Stanford, got his master's in physics at Stanford, and now is getting his PhD in physics from UC Santa Cruz, focusing on, what is it you're focusing on exactly, Joey?
So, I'm studying exoplanets mainly. So, some observational astronomy and astrophysics to try and understand how planets around other stars form and what their physical characteristics are and things like that. Yeah.
Yeah. Wow. Amazing. Give it up for Joey. Physics extraordinaire in the building. Hence him being an atom. What kind of atom are you, Joey?
It's hard to say. Maybe I gotta pick a good one. Maybe like iron.
Yeah,
Iron's
iron.
a pretty good atom.
We love iron here on Coby's Brain.
It's important. We'll come back to that later. Actually, it's an important element in astronomy, astrophysics.
Why is that? Why is iron so important?
It is the most stable atomic nucleus. So,
what's the significance of that?
So, not to get too far into the detail, they're too far ahead of ourselves, but it's very important in kind of the deaths of stars because you can't fuse iron nuclei, and so that causes things like supernova explosions. So yeah, it's important stuff.
Awesome. All right, so our first question, basically, Coby's Brain is a big fan of stars, very impressed by stars, trying to figure out what's going on with those things. So we wanted to interview Joey today to talk about stars. So, Joey, what is a star?
Well, it's a great question, first of all, Cubs. Stars are really special objects in astronomy and astrophysics. They're basically just spheres of plasma, really hot plasma, held together by their own gravity. But really, like the primary function of stars in the universe is that they are chemical factories, basically. So like when after the Big Bang, when the universe was created, the Big Bang only created a couple of elements. It created a lot of hydrogen, a lot of helium, and then like tiny amounts of lithium and beryllium. But that was it. There's no carbon, for example. There's no oxygen. There's no nitrogen, all the important things that are important for life, right? So how did all of those elements get created? Well, they're born in the core of nuclear fusion and in the deaths of stars, in supernova explosions, because it takes a ton of an enormous amount of energy to create these fusion reactions to create heavier elements. And stars are where it all goes down in the universe. So yeah, a simple way to think of a star is kind of like a chemical factory for the universe.
Wow. That is incredible. Basically, the curiosity of stars in a lot of Coby's brain and stars in a lot of ways comes from when I was a little bit younger. I was staring at some stars. I was like, what if these things are alive? And so I've been talking with Joey, and, you know, stars are interesting because they're born, they live for a while, and then they die. So I guess we're gonna talk.
Yeah.
We're gonna go into a little bit about that whole star life cycle situation. I guess with the birth. So Joey, can you tell us a little bit about how are stars created?
Yeah, absolutely. So you're exactly right. Kind of the way to think about a star is kind of like a life cycle. So they're born, then they kind of live for a while in a stable state, and then they die in some way. But to start off, stars are created basically in these. There are out in space these giant clouds of diffuse gas and dust called giant molecular clouds, or GMCs. And so these are enormous clouds, many, many, many times greater than the size of our own solar system. And when pockets of these clouds become dense enough, it called the Jeans instability. And this is where the pressure of the cloud is too low to stop gravity from collapsing the cloud in on itself. So these pockets in the cloud start to collapse in on themselves, pulling more and more dust and gas with them because of gravity, right? And so the cores of these collapsed pockets soon get dense enough, and as gravitational potential energy is released, as things are falling inward, that's converted into energy and heat. And so the cores begin to heat up and form a star. And so this whole process takes a couple million years, which is very short. As this material is falling onto the surface of the protostar, it also has a little bit of angular momentum, so it's been spinning in some way. And angular momentum is conserved, so that means when it falls on the protostar has to start spinning. And the whole kind of cloud around that protostar gets spun out into a flat protoplanetary disk. Just like when you spin a ball of dough for a pizza, it spins out into a flat disk. And so that disk is what becomes the nursing ground for planets. And so inside that disk, different pebbles start colliding with each other, and planetesimals start to form. And a lot about planet formation is still unknown, but these planets start forming in these disks. And so once that protostar with this protoplanetary disk, as it's called, around it, gets hot enough to about 10 million Kelvin, the core of the protostar starts to burn hydrogen, which is to say it starts fusing hydrogen into helium. And this is basically how the star becomes what's called a main sequence star. And so the whole process of star formation probably lasts, like I said, like 100 million or 100,000 to 10 million years, based on how heavy the star is, which is really short in the lifetime of the star. But once it's done, you get fusion in the core of this young star, and potentially some young planets orbiting around it. And that's how stars are born.
Wow, that's pretty crazy. Pretty like it's like how we're born, but way bigger.
Yeah.
So my next question, if we continue thinking about this like metaphor of stars being born, they live and then they die. They're like people in that way. Let's keep that line of thinking of stars going. Tell us about the life of a star, Mr. Joey.
Yeah. The perfect follow-up to how stars are born. I mentioned kind of there's a key point in the formation of stars when the cores of these young stars get hot enough to start turning the hydrogen into helium through nuclear fusion. So once they start doing that, they've reached what's called the main sequence, and this is when stars are relatively stable. This is the majority of their lifetime. Like the sun is a main sequence star, for example. And so stars are, just to step back a bit, stars are constantly playing a game of push and pull, basically between pressure and gravity. So pressure wants to push things outward away from the star, whereas gravity wants to pull them back in. And nuclear fusion inside the core of a star releases a ton of energy. And this is what powers the pressure in a star. And that pressure is exactly balanced by the star's own gravity, which wants to hold things together. Constant push and pull, but it's perfectly balanced so long as there is hydrogen in the core of the star to fuel this fusion reaction. Just to go back to the sun, a star with the mass of the sun will live on the main sequence, constantly fusing hydrogen into helium at about 600. The sun does, I think it's like 600 million tons of hydrogen per second, converts most of that into helium. And it does this for 10 billion years. So the sun is middle-aged. It's about 4.5 billion years old. And the sun will keep living like this in its current state for another 5 billion years or so. So this is where it starts to get a little more interesting. So stars, they're on the main sequence. A sun-like star is on the main sequence for 10 billion years. Once the sun is exhausted all of the hydrogen in its core, it doesn't have any more fuel left to fuel this, to keep this perfect balance between pressure and gravity going. So what happens is the core of helium that's inside the sun, or in the future, what will be inside the sun, begins to contract and heat up because it doesn't have enough energy to support the pressure, and the gravity begins to win out, and the core begins to contract. And when this happens, the whole star sort of starts to expand, and it becomes what's called a red giant. And so for the sun, when it does this in 5 billion years, the sun's radius will become so large that it's going to consume Mercury, Venus, and potentially the Earth too. Whoa. It's just going to become so large, it's going to eat them up. Yeah.
So are we now into the death of a star? Is that what we're basically covering now when we talk about the red giant expansion?
Yeah, you're exactly. I kind of segued, I guess, into this red. That's right. The end of the life of stars.
The death of the star.
Yeah, it all begins. The death of a star. Yeah, it all starts when that star runs out of hydrogen to fuse. Is when it all starts to go downhill. So
we need our hydrogen.
Yeah, exactly. But yeah, so I mean, the Earth, 5 billion years or so, it doesn't look too good for the Earth. Definitely not for Mercury and Venus. Those are going to get eaten by the sun. Europa is this moon of Jupiter that is covered in ice. Um, but when the sun expands, Europa is like at a perfect location where it'll become kind of warm and temperate, and all the ice will melt and turn into liquid water, and so that will be like the new solar system vacation spot.
So we'll all be chilling on Europa.
Yeah, exactly. Book your Airbnbs on Europa now.
Thank you, Joey. You have just taken us through the life cycle of a star. We love that. We love that. That kind of.
If you, I was gonna say, there's one bonus thing if you're interested. That we've been talking a lot about kind of the life cycle of a star about the same size as the sun, and we talked about how it becomes a red giant and expands, and after that point it kind of loses all its mass eventually and just becomes an exposed core, what's called a white dwarf, and it kind of just, it's very hot and very compact, but it kind of cools off and that's it. If you're looking for a more exciting death for a star,
we want maximally exciting deaths of stars. We want the most exciting death possible.
Yeah, I wanted to make sure you heard this part. Because it ties into everything about the chemical evolution of the universe and why stars are so important. So massive stars are about 8 times heavier than the sun. Once they finish burning all of their hydrogen, they also start to expand and they become what's called a red supergiant. So I don't know if a little while ago there was all this talk about the star Betelgeuse, which was dimming, or maybe you watched Beetlejuice the movie. Well, Betelgeuse is a red supergiant, so like I think 11 times more massive than the sun. Wow. It's huge.
Give it up for Betelgeuse. We love Betelgeuse here.
Other than being a family-friendly comedy, Betelgeuse is a red supergiant that could potentially turn into a supernova at some point. And so a little while ago, people were... so when these massive stars become supergiants, they start to pulsate. There's a lot of stuff going on. The surfaces of these stars actually start to pulsate, and it's kind of like a heartbeat as the star is on the verge of its life. And they change in brightness, and these can kind of be signposts that the star is going to go supernova soon. These red supergiants, they can't burn any hydrogen, so they use carbon, then neon, then oxygen, then silicon, and then they get to iron. They fuse silicon about before.
Give it up for iron.
Can't fuse. Yeah, exactly. Iron is the most stable nucleus, so you can't go past. So that's pure iron. These stars have a core of pure iron, right? And basically, they can't fuse iron anymore, right? Or they can't fuse iron. So gravity. It was this push and pull between pressure and gravity. You can't fuse anything heavier than iron, so gravity wins. And the entire star, this is what's called a core collapse supernova. The entire star begins to fall back in on the solid iron core because gravity is winning out. And what happens is that all that material falls on the core, but the core is so dense and degenerate that it can't be compressed any further. So it basically bounces off the core, and that's what causes this massive explosion. And so that's your supernova.
Wow.
And the final, just to put a cap on it, the final state of this exploded star, depending on how massive it is, it'll either become a black hole or the core will become a neutron star, which are pretty crazy objects. But the takeaway is that these explosions so high energy that they create these rare elements, like gold, for example. Like any of the gold we find on Earth is because it was formed in supernova explosions. And so, like, it goes back to stars are like the chemical factories of the universe. And if we want to think about kind of like stars as being conscious or like having a life cycle just like us, we are, the carbon in us, the iron, all the heavy elements in us and all around us are because of stars and from the life cycles of stars. So
wow, we got to give it up for stars. Thank you,
stars
for our elements.
Yeah. So maybe in that sense, they really are conscious codes.
Ooh.
Yeah.
That actually brings us to one of the main questions that Coby's brain has for Joey, is kind of this somewhat crazy idea. We're talking about stars in terms of their life cycles, and stars are energy, and energy probably has a lot to do with our consciousness, theoretically. Like, Joey, do you think it's theoretically possible that maybe these stars have consciousness? Maybe they're just like us, living up there in the sky, hanging out with other stars and, living their lives. What do you think?
Yeah, I mean, I think it is definitely an interesting idea and definitely cool to think about. Like when you look up at the stars and think about them or someone or something looking back at us, right?
Yeah.
Thinking the same things. I don't know if stars are conscious in the same way that we think of human consciousness.
Sure.
But maybe it just, maybe they're conscious in sort of more like a overarching universal consciousness, if that makes sense. Like, the way I like to think about these things sometimes is they're so far away, but they're out there. And it's kind of like, the tree that falls in the forest with no one around to hear it. They're still out there living their lives, doing their thing, even if we're not around to be able to interact with them or see them or visit them. I mean, maybe some of their consciousness lives through us, like just in the way that
elements that they've given us.
Yeah, through the elements that they've given us, and enabled us to actually ask these questions in the first place.
Yeah.
So,
wow.
Hey, when the Earth gets consumed by the sun, there's going to be some violent.
We're chilling on Jupiter's moon.
Europa. Well, this is even after. Eventually, Europa isn't even going to make it, so we're going to need to. We're going to need Matthew McConaughey and Tom Hanks and all the pilot and astronaut actors you could think of to help us find somewhere else to live. But When the sun, it's going to go through this period of mass loss and throw off all of its outer layers, and that's going to include the shoot up and spit out remains of all the planets, and that's going to form a giant cloud of kind of gas and dust, and that kind of brings us back.
Yeah, so this is how a new Earth and Sun could form after us.
Yeah, maybe. Exactly, and
Cool.
The exciting
that.
thing, I mean, that's so far away, so we don't have to worry about it. But
yeah, we got
maybe,
some time.
Another thing I'm doing in my research now is like, right now in astronomy, everybody's searching for Earth 2.0, right? So
yeah,
maybe there's another planet out there orbiting a different star right now that is where people are on their own version of Coby's brain, talking about the stars too.
I mean, considering there's hundreds of billions of stars, hundreds of billions of galaxies with hundreds of billions of stars, right? Like, seems pretty likely, honestly, right?
Yeah.
You think so?
Yeah, I mean, this is a big topic of this question has been looked into a lot from a lot of different angles in astronomy and astrophysics, and yeah, it all gets down to it's called the Drake equation, which tries to combine all the probabilities of how many stars are out there. Of that many stars, how many are the right temperature to harbor life? How many planets are out there around each of those stars? So it's definitely something that people are thinking about. But if anything, I like to think about, like, look at any star in the night sky. There's a good probability that it has planets around it, let alone multiple planets.
Wow. Yeah, theoretically, totally, right? They're
hit the tip of the iceberg.
Yeah.
In terms of discovering planets. So.
All right, Joe, we got one more question for you here on Coby's Brain. What are some questions about stars that you still think, or that you think we're gonna have some cool answers to in the coming years?
Yeah. So this is an awesome question because it gives me a chance to highlight what I think is probably like the most exciting thing coming up for astronomy and astrophysics, and really really the whole world, which is the James Webb Space Telescope, or JWST.
Tell us about that.
So JWST, yeah, it's going to be this space telescope. It's being built right now, and its launch date has been pushed back over and over again. There's been some delays in the building, but right now I think its launch date is set for Halloween 2021.
Wow.
And so this, if you Google any images of this thing, it looks kind of like a Star Destroyer. It looks super cool. And its mirror, so its primary mirror, is 6.5 meters large, 6.5 meters across. So that's like 20 feet, and it fits in they have to fold it up so that it can fit inside the rocket. But anyway, so JWST is going to have a bunch of specialized instruments on it, some of which are going to be spectrographs. So they measure the color, the spectrum of light from different objects that specialize at longer wavelengths towards the infrared. So if you've ever seen like a thermal camera that creates images at infrared wavelengths, kind of like that. And so it's going to be key to understanding this era of star formation that we're talking about. There's a lot of gas and dust in the way that makes it hard for visible light to get through, but you can see the star formation going on at longer wavelengths. So yeah, JWST is going to be really exciting for us studying star formation because of its specialized instruments at near infrared wavelengths. So maybe we'll be able to even see some young planets forming around stars. So not only star formation, but also planet formation. Yeah. If definitely give it a Google. The JWST Space Telescope. It's gonna be awesome.
Hear that, viewers? Give it a Google. Joey Murphy, thank you for being on Coby's Brain. It has been a major honor to have you, and
my pleasure.
We look forward to seeing the amazing discoveries you make in the world of astrophysics. Give it up for Joey Murphy.
Well, when I make them, Coby's Brain will be the first to know. So.
Yeah.